We will continue with the time complexity, and let's introduce the logarithmic time complexity, O of log n. Algorithm runs in proportionally to the logarithmic of the input size. Let's take an overview about the graph of the logarithmic, y equal log x in the blue and y equal ln x in red. We are interested in studying the log x. So, or log n. This is the same concept. So, as we see, the algorithm run in proportion to the logarithmic of the input size. For example, our cards are ordered and split into two parts. If I told you go and get the 10 of the spades, if we are working with the linear, they are ordered. I'm telling you that it is ordered. So in case of linear, I need to go all of these, passing through these 13 plus 13 plus 13. They are equal to 39 until reaching 10. So I'm going to search about 48 cards to reach 10. But in case of logarithmic time complexity, I am going to divide this deck into two main parts. The first part, it will include the diamonds and the clubs, and the second part will include the hearts and the spades. So I'm going to search for the 10 spades, and they are ordered deck of cards. So I decided to separate the cards, all the cards, to two main parts. The first part contains the diamonds, and the second part contains diamonds and clubs, and the second part contains the hearts and the spades. Remember, I am searching for the tens of the spade. 10 spade. So automatically, I'm not going to search in this first part because the spades are in the second part. I have removed half of these cards. They are 52. I have removed 26 cards. Now, if they are ordered in the same way as picture told us or showing us, I can remove all the red things because spades are black. So I remove the red, the hearts. So the spades are now 13. I have removed till now 26 plus 13 is equal to 39. I decided to split, since they are ordered, I decided to get rid of half of these cards because the 10 is half of the 13 is 6.5. So I removed 6 cards. I have now 7, 8, 9, 10, J, Q, and K. Now I need again to get rid of half of these paper cards. So I removed these 3 because 10 now is the middle and I get this. In this way, I am one more time we will divide into 2 and we can see that the 10 in the middle element. Okay, so we are not looking through all the elements of this card, of these cards. Okay, we are not searching one by one for these cards. We are just eliminating half. Every time we eliminate half of these cards in order to get a certain level. Okay, so this time complexity is a logarithmic time complexity. Okay? Now, Let's go to the coding. We have in a logarithmic complexity an example of a for loop that it is going to print system.out.print hello. But this time it's very different. You see, guys, int I, it will start from 1 and stops at n, but this time the iteration will be increased every time by 3. So every time I will loop through and add 3. So if I have 30, I entered n equal to 30. Okay? This loop will print system.out.print hello. Okay? So this loop will not print 30 times the hello. Okay? It will print 10 times because we have n now equal to 30. And every time I is added 3 times. So it starts by 1. 1 plus 3 is equal to 4. Now n equal to 4. But it is the first iteration and printing the hello only one time. I becomes I equal to 4. And I becomes 7. Then I becomes 10. So these are the iterations through n equal to 30. This is very important because we are not going through every element. We are of n because n from 1 to 30 we are jumping at the third level, at the third number. Every time we are skipping 2 numbers and adding the third one. Okay? So the total time here is O log n. This is the time complexity for this example in the loop while we have adding I plus 3. The third type of time complexity is the quadratic time complexity, O of n squared, represents an algorithm whose performance is directly proportional to the square size of input data. Think about it as linear, but it's a square. So, for example, if we have a card deck here, and I told you to pick the first card, you will pick the ace of clubs. And I told you get all cards with the same number. So you are going to search all the deck for the aces. Okay? So you search all the aces here. Ace of diamond, ace of clubs, and ace of diamonds, and hearts and spades. Okay? These are the 4 cards. Okay? So you every time you are searching for a card for ace in the diamond, you loop through all the cards. Okay? And then you are going to search for a heart. So you loop all the hearts and the spades also. So we are picking a specific card with a specific number among all of the cards. So if we are choosing only one card, it will be linear. But if we are choosing a specific number, that can be all cards with the same number, we are using a quadratic time complexity. In terms of coding, the running time of loop is the running time of the statement inside the loop, including tests multiplied by the number of iterations. Let me show you this example. We start from here. This is a loop having having n times. Okay, put in your mind that we are going to loop through this red one n times. Okay, And we have here a for loop and having also n. So this is a nested loop. And we are going to loop through this green statements n times. So we are going to loop n times in red, and every time we loop inside n, the red n, we are going to execute n times the green one. So this will be printing if we are entering 5 here, n equal to 5. So n equal to 5. I will go and loop 5 times this loop. And this will also printing hello 5 times every time it will be executed. So 5 times 5 is equal to 25 times. So therefore, we have the total time here. Since we have learned that system.out.print, this is not related to any input of the user, which is n. So it is a constant. So this constant time in blue correspond to C. Okay. And this n in green refers to this n, the inner loop inside the outer loop. And this n will be referring to the outer loop. Okay? So the outer loop is n multiplied by the inner loop n, and this statement is constant, so it will result in Cn squared. And since we have one term and we took the highest degree, and the constant is removed, so it will result in O(n) squared. So this is the time complexity of the quadratic